Hey everybody, I'm a super AP from first period, and we're going to take some time today to go over one of the fear response questions that was assigned to you guys some time ago. I guess I should start off by saying that I hope you guys are all doing well. I hope you guys are all safe and had some time to relax and unwind and spend time with your families. Also hope you guys have had some time to work on schoolwork and whatnot and have found the time to work through your schedules in a timely manner. I hope you guys are all doing well. So the goal today will be to go over this fear response question that was assigned to you guys. It wasn't too bad of a question, but it primarily covered topics that you guys have already learned in not much great detail, but to a certain extent where you should be able to apply it to these problems. And the goal today will not be to necessarily teach you something new, but to go over this fear response question and iron it out to a point where you guys can apply it pretty comfortably to any scenario you find it in. So if I need to jog your memory, the question pertained to mainly array lists. The inner workings of the problem were nothing too complicated. You just had to work with array lists to properly allocate data, and the data was just strings. It wasn't something too complicated. Had nothing new, nothing too complicated. The areas of difficulty with this problem would primarily be trying to hop over and avoid the array index out-of-bound exceptions and whatnot, and null pointer exceptions that we do end up encountering in these types of problems. So more specifically, this question had to deal with a class they defined called word pair, a fancy way of saying just two strings. The class declaration that we see inside the fear response question of the word pair thing isn't all that complicated, and it's pretty generic. If you notice, all you have is this constructor, not even worthy enough to mention what it does, and these two getter methods, get first and get second, which just allow you to access the two strings inside this class that they've defined. Nothing out of the ordinary, something very basic, and when you see something like this, you already know that the question isn't going to be understanding what the word pair does. It's just going to be allocating the data properly using this word pair thing. Obviously, it's no different than just having, for example, a two-element array of strings. Really does nothing differently. It's just a class in itself. The second class that they've defined here, and the one you're going to be working with most of the time with the problems, both parts A and B, is the word pair list class. And this, again, is really nothing new. It's just a fancy way of allocating memory. It's the word pair list has only one field variable, and the one field variable that we find is this array list of word pairs. Word pairs were defined in the previous class, so we're really just defining different ways of storing information, and the problem is going to be working with those. So the array list is going to contain pairs of words, the word pairs. So we have a few examples here. You can scroll down here, and in these little boxes where it says class information for the question, it gives you a little shorter crash course or TLDR rundown of the information that you're going to have access to for each question. So if after you read the long blocks of text, you're not convinced with what information you can and cannot use, you can just scroll down to these little boxes and see what information you actually have access to for the question that you're working on. So here's an example here, and we have more later. So what exactly is the word pair list? The word pair list has this array list called all pairs. And all pairs include the object of type word pair, which were defined in the previous class. What exactly do we put inside this array list? Well, if you take a look at the constructor, you'll see that the constructor takes in a string array argument. The string array argument isn't going to have pairs of strings like we defined in the previous question. It's just going to have string literals, objects of type string. So we can't necessarily stack them inside this array list just yet. And if you read the question, what it tells you is that you want to take all combinations of two string objects and put them inside word pair objects. So here I've noted with comments the different parts of the question that we're going to be working on. They both have to do with this word pair list class. The first part is to make the constructor of the class, and the second part is to make some very simple method. The second part of the question is extremely easy and it's almost not even worth going over. It's just the first part of the problem that you need to work on in the most detail. And I guess this brings up a decent talking point about the AP exam. When you're working on these exam questions, you're often going to have these part A, part B situations, and I mean, it's going to become pretty obvious that usually part B is going to be an extremely easy application of the stuff you worked on in part A. What this ends up meaning is that if you spend all your time doing part A, and maybe you're not so sure about your solution, whether it works or not properly, when you move on to part B, you always assume that what you've implemented for part A works properly, and if you need to use it, you are expected to do so. So if you work around and basically re-implement the data in part A during your work on part B, then you will get marked off points in the AP exam. So when working on part B, always assume that the information you have in part A worked properly, it compiled properly. Assume that you have no compile errors and use it whenever it's applicable. So never re-implement something from a previous question into a more recent question, otherwise you will get marked off for that. So, as I previously mentioned, the way we're going to fill this array list of word pair objects is to take all possible combinations of pairs in this array that we have. So, we're going to have a finite amount of variables, finite amount of strings in this string words array, and we're going to take every possible pair of strings from that array, turn them into word pairs, and then put those word pairs into the word pair list. So, and we have several cases that we should you can already tell before. At this point is that we're going to need some sort of a loop. In this case, the functionality that we're going to require is going to be a nested for loop next to the loop. And before this is completely obvious, I guess I should take it into a case-by-case scenario. So suppose we just had one for loop, which is pretty obvious that we're going to need because we're going to need to iterate through objects in the words array. So suppose we did have this array. We're going to have I going through all the separate variables inside the array. So in this first case, let's take the case when I is equal to 0. So I'm going to declare this other variable j, which is going to pertain to the other string object we're going to take from this array because we need to form pairs. So when we have I being equal to 0, let's just say that we have this other index that pertains to the other string. We're going to have j needing to be equal to the objects at index 1, 2, 3, 4, and so on, all the way to the end of the array. And we can do this moving forward. We'll have case 2 when I is equal to 1. We should have j being equal to all other objects inside the string. So if we have j is equal to 1 as the case that we're taking a look at, then we should have a pair that, if we have I equals 1 being the case that we're taking a look at, then we should definitely have j equals 0 being a pair of that. We should have j equals 1 skipped because you never take pairs of the same string. You have j equals 2, 3, 4, and so on all the way to the end of the array. And I guess I can do one more here. Case 3, we just have I being equal to 2 and j being equal to everything else. And what you should hopefully notice at this point is that if we literally take every combination, if we literally take I iterating through this array and we take j being equal to every other index value inside this array, we notice that starting from here, this case 2, we are overcounting a bit. Notice here how we have the pair I equals 0 and j equals 1. And inside this next part, we're going to have the pair I equals 1 and j equals 0. Now I and j are arbitrary, and we're dealing with the same array here in both cases. So the pair 0, 1 and the pair 1, 0 are going to be the exact same. So when we're overcounting here, we already noticed that we want to skip all previous pairs that we've worked with. And the structure of this problem is going to end up looking a lot like a nested for loop, where you're going to start one of your counter variables at 0 and iterate through the entire array, and that's going to be your outer loop. And your inner for loop is going to start at 1 plus your first counter variable. So you're going to have I going through the entire array. And let's say you're going to have the second counter, your second index value j, starting from all values greater than I and iterating through the end of the array. So here, I'll show that functionality right here. Here we have it right here. We have for int I equals 0, I is less than or without length, I plus plus, standard stuff, and inside the nested part of the loop, we have this in j going from I plus 1 to where's that length, which is what we've demonstrated in this case-by-case scenario. For example, look at the 1, 2, 3, 4, and the 2, 3, 4, 5. Looks like where we have this staircase ladder sort of structure that we're working with, where we omit all previous pairs that we've made by taking j to always be greater than I, because if we take values of j that are less than I, we notice that we get repeats and we start over counting the possible pairs that we can make. So anyway, moving forward, and this j equals I plus 1 thing, hopefully that makes you cringe a little, because usually you don't want to do things like that. When you have I going to the end of the array and you have j being equal to I plus 1, the thing that you should already be weary about is getting an array index out of bounds exception with this I plus 1 business that we're doing here. But here, I'll make a comment about it here. Think about why it actually works. If you do I plus 1 here, you may think that it's going to give you an out of bounds exception, but it turns out it actually works. I mean, an easy workaround is obviously to go to where's that length minus 1 in the I for loop, but even if you don't here, it actually ends up working fine. If you take a look at it here, we have j starting at I plus 1 and then going to where's that length. So this condition, j is less than where's that length, is checked before every time the j for loop runs. So even if we do have j being equal to where's that length, or being greater than where's that length for that matter, then this for loop won't run. So obviously we are going to have j being equal to where's that length at one point, because I goes to where's that length minus 1 and j is always equal to I plus 1. So in that final case, we're going to have j being equal to where's that length, but since it's equal to where's that length, the array simply won't run. So, or I should say the for loop simply won't run because the condition is obviously checked before. So it does look a little scary, and obviously that last case, that last run of the for loop is going to produce no results. So you can just skip it if you want by doing what I said before, having the first for loop run to where's that length minus 1, but this way it doesn't give you an error. So I just thought I'd mention that because that may be an area of contention or an area of confusion when you're working on this problem. So let's see what else we have. When working with this second method, int matches, so the way this method works is, if at any time you need, by the way, go ahead and pause the video and pull up a reference, look at the free response. I'll do that a couple times here too, but I don't think we need to do that for the second part of the problem. The second part of the problem, as long as we assume that everything in the first part ran correctly, we're going to be working with the all pairs array list that we've created, and we're going to be taking a look at each pair individually. And if in any of those cases we have string 1 being equal to string 2, so the two strings inside the pair are equivalent, the same, then we count. Basically count every single pair that includes duplicate strings inside the all pairs array list, starting from 0 to obviously the array list size. So I mean, all this is here is, again, just another for loop, so notice that the whole problem is just working with for loops properly. In this case, we're just going to be counting up, so here, we just create a counter variable, int num equals 0, and obviously, if at any point we find the proper pair, if it satisfies the conditions we're looking for, we're just going to count up and return the value at the end. Notice it's a int method, nothing here is a void method. So, moving forward, let's see what else we have. So yeah, here, at this point, let's try to compile what we have so far. Let me go to the console right now. Let's see if what we have so far at least works correctly. And oh yeah, it looks like we found our first mistake that I made here. In the second for loop, it looks like I forgot to do the J++. Simple mistake, forget about it. Okay, so moving forward, hopefully it works. And okay, it looks like it compiles properly, so let's see what else we should do. So yeah, at this point, I was hoping that everything worked correctly. So at this point, I just tried to show you guys some cases and try to show you guys that it indeed works correctly and hopefully make it more intuitive by seeing the cases. But let's see. What the hell am I looking at? What is going on at this point, right? So yeah, at this point I kind of went nuts and didn't feel like updating Java or whatever that stupid error was telling me to do, so I tried to replicate this in an online compiler. That didn't go so well, so here we are back here again, and I'm trying to work through a possible causes of these errors that I'm getting. So alright, so let me step in here. So at this point, when I was live recording the progress on this problem, I was getting this stupid error. I was getting a null pointer exception after I fixed the Java version error, because apparently I was using an earlier version of Java during runtime than compiling, so the differences of those versions were giving me errors. So anyway, fixed that. Thought I was past all the errors, but turns out I missed something else. So I was getting a null pointer exception, and it turns out I shouldn't even use that word. It was just a really dumb mistake on my part. I had this private array list all pairs declared at the top. I declared the variable at the top, but notice how I never actually construct the object. I never actually have the array list all pairs equals new array list shenanigans. So that was what was giving me an error for a little bit while, and you can see here I'm messing around with the program trying to debug it. Nothing I seem to do worked until I finally figured it out, until I finally saw it, which, yeah, when you work on larger problems, when you have several parts of the problem, it's a little bit harder to see when you make a dumb mistake, like a semicolon, or in this case, forgetting to declare a variable properly. So tips for that would be, I guess, to go slow and always assume that you just made a mistake in the previous step that you did. So double check what you do, I guess, is the moral of the story. And yeah, let's get back to this problem. So yeah, at this point, I declared the array list inside memory. I construct the object, and what we should do now is take a look at some examples. Inside a client file, I have this starter.java in the same directory, and what we're going to be doing is taking a look at several cases of the methods being ran and the methods producing results. So what I've done here is I've put a print statement inside the constructor of the all pairs class. So it's going to print out every object inside the array list. So we can take a look at that. And then we're also going to be printing out the result we get from number of matches. So yeah, so okay, after I get this ironed out, after I fix all the dumb mistakes I was doing, we take a look at a couple cases here. For example, here I just filled an array of length 4 with the string A. So every pair that we're going to get is AA. And let's take a look at how many pairs that we get. Actually, we get 6 pairs, which is what you should expect mathematically. You take all the pairs, for example, we'd have the first A matched with 3 other A's, the second A is matched with 2 other A's, and the third A is only matched with 1 A, so we have 3 plus 2 plus 1. You should expect to see 6 pairs, which hopefully gives us an idea that this thing is working correctly, and the number of matches obviously is 6, because filled it with the same variable, you're going to get all of them matching up. And let's see. I don't know if there's any comment I can make about this other than what's been said. Yeah, here's another example. I'm going to switch up some of the strings that we had. So we're going to have one pair here. One pair is working properly. Oh, okay, so yeah, it looks like at this point I again made a dumb mistake. I forgot to count up. So after we fix that, we come back here, and here are a few examples. I do the all A's again, and here I do an example where some of the strings are switched around, so we should only have one pair. We have two A's, and every other string is different. And as we can see here, after it prints out the entire array list, we have every possible pair. That's correct again. We have 6 pairs, obviously, since we had 4 strings inside this array. What we also notice here is that, as expected, the number of matches that we have is 1, because we just had that AA pair and everything else is unique. So yeah, that's basically all there is to this problem. Might do a little crash course, little review. So what did we have? If we look at the problem, what's being asked of us isn't too complicated. We're not combining too many areas of computer science. It's literally just one thing. All we have is this string object, and we're going to be stuffing that string object into different categorizations, into different data structures. So first thing that we do with the string is we put it inside an array. That's what we're going to accept as an argument for this word pair class that we had first defined. So first things first, put strings inside arrays. Next, what happens is we take that array and take the strings from that array. We put strings in this mysterious object that we've defined. Very simple. The word pair class just has objects of 2 strings. So it's another data structure that we see defined in this question, the word pair structure. And finally, obviously, we have the array list defined at the end. If you're unfamiliar with array lists, this should be a good exercise to train you guys, because although they don't appear too often, array lists are always implemented into the computer science free response question, so you can use them at your own will. I mean, the truth is, this question could have been done entirely with arrays, but since we defined the array list as a field variable inside the class, we ended up going with that. So on the computer science exam, I think you can always assume that array lists are properly implemented, imported, the utility. So yeah, where was I? So again, so this question just has to do with putting strings in different data structures, and obviously the final data structure is pairs inside an array list. Pairs just being strings, array lists just being collections of those objects. So in the end, we just have strings being put in these funky arrangements that the errors that we get from this question and the hardships that we encounter, the roadblocks, aren't necessarily thinking of the algorithms, but trying to clean up the small mistakes we get here and there in defining these loops and the null pointer exceptions and whatnot. So problem is a good exercise, nothing really too complicated. I don't expect you guys to learn anything necessarily new from this, but I hope you guys are able to at least iron this one out and be comfortable enough to apply this kind of knowledge, because obviously moving forward, you guys are going to be dealing with these 2-dimensional arrays and these weirder data structures. 2-dimensional arrays, obviously what we've had here is we use the nested for loop. What you'll find in the future is that nested for loops are very good for iterating through nested arrays or 2-dimensional arrays. So yeah, one more thing. This is the first of these videos that I've made. This is the first time I've appeared here. I do plan to contribute and make more videos in the future, and I'd like to improve the production quality on these videos. So if you want, you can go ahead and leave feedback, and I'll try to take the tips and roll with them and see what I can improve about these videos. So yeah, what I've noticed is that it's been really hard to find the private place to record the audio. So go ahead and tell me what you guys think about these. I'll change them to your liking. I mean, these videos aren't about me, right? Videos are to help you guys, hopefully. So yeah, it's been a good time. Hope you guys found this useful, and hope you guys continue to stay safe. Good luck with your work.